So now, as you can see, I've got the car call to base. I'm going to use this one for the actual real how you're supposed to wiring this thing, specifically because it's got those 2-watt resistors. If you have the car call tube base and you want to wire it the way I do, you're going to have to figure out some way to put this resistor in. You can find this resistor online from eBay. You can also pre-order them from any sort of electronics company, or you can just use a car call base if you have one and use that. If you want to recreate one of these bases, I don't advise you do, because obviously you're dealing with vacuum tube technology and lots of things can go wrong. I'll have a little schematic in the description that'll show you how you can wire a tube base exactly like this or one of the car call ones. So anyway, with that in mind, let's get to actually wiring this thing. So we used 120 volts AC on the last tube base to actually get these tubes up and running. We used it as both the trigger voltage, which actually allowed us when we touched the tube for it to actually trigger, and it also allowed the we also used it as the anode applied voltage, which is what caused it to actually light up and all that. Now, we are still going to use 120 volts AC for the trigger voltage. Normally they use 150 AC, but that's kind of hard to get around here, especially with a Variac. Sometimes they go up to 150, sometimes they don't, but 120 works fine, so we'll use it for that. And the only change we are going to make is how we actually apply the anode voltage. Instead of using AC, we will use DC, and we will actually use 135 volts instead of 120. Now, we are using more than we did last time, but because we are actually using these resistors on the tube base, it will in turn cause the tube to not explode. So, in order to actually wire this thing, we need a Variac. We need an isolation transformer, and that's important. You do need an isolation transformer, and I'll explain why soon. I'll just explain it now. The reason we need an isolation transformer is to isolate our DC source from our AC source. As you can see, our DC source is right past the isolation transformer, and if we didn't have that isolation transformer there, when we connect the 120 volts AC live wire to the cathode of the tube, as you can see, if we didn't have that isolation transformer there, then the AC would in turn go through the full bridge rectifier and come back. There would be very little resistance, and it would in turn cause a breaker to trip. And I know what some of you are thinking, well, couldn't I just use the Variac? Doesn't the Variac provide isolation? No, it doesn't. I know a lot of people make this mistake. A Variac is a type of auto transformer, and while it may have the name transformer in its name, it is fundamentally different from an isolation transformer. A Variac or auto transformer only uses one coil, so both the input and the output are in turn connected together. Please don't mistake a Variac as a type of isolation transformer. There are some people who have made that mistake, and it has caused them great pain. We need some sort of rectifier, so we could use a full wave rectifier. It's just 4 simple diodes arranged in this configuration here. And we need a capacitor, and preferably one that we can use to smooth out the DC. And that'll also come in handy later. So now, with all our components, we just need to wire them. And I'll just do a little jump cut here where I actually wire these things, and I'll explain what it is in just a second. So, if you guys cannot guess by the fact that there's a lot more table stuff here on this table, I have done quite a bit in this jump cut. So I'll just go over a brief explanation of what exactly I've done here. So obviously I have this Variac, and I have it set at 20 volts. The reason for that is because this transformer, it would be ideal if it was a 1-to-1 transformer, but it's not. It's a 120 to 12, I believe. It's either 120 to 12 or 120 to 24, but either way, in order to get around 135 volts DC off of it, I need to set the voltage to around 20 on the 12 side, so that'll give me around somewhere around around, I'd say 110 volts on the output, and that'll go into the full wave rectifier, which turns the AC into pulsating DC. Now, we could in theory put pulsating DC across this tube, but I've tried it and it doesn't really work. So we use the simple capacitor here. It goes up to 300 volts, so there's no chance it's going to blow up. And that smooths out the DC, and I just modified some settings, so I got a clean 135 DC at the output. Now, important thing to note is that a capacitor and it holds a charge even after the source has been disconnected, and that source is 135 DC, which can be lethal. So what I've done is I have taken a bell from another elevator that is being replaced, and I've just connected its leads across one side, across the bell, and to the screwdriver. And when I turn it off, all I need to do is take the screwdriver and tap it right there, and we'll should hear something from the bell, and we might see a spark, and that'll let us know that we've discharged it. So now, and just to mention, all these things that I have here, those are just because I don't have an actual source that can current limit and put 150 volts AC or 135 volts DC across these things. If you have something that does that, you don't need to jump through all these hoops. But this is just how anyone who has a variac, an isolation transformer, a capacitor, and some diodes can do it. So, in order to actually run these things, it describes the anode as being more positive than the cathode. So we take our red, which is the positive, and we need to connect it to the anode, which on this one is this pin right here. And like I said, you guys should know which one this is beforehand. If you don't, I suggest you do find out. And now we connect the other end, the negative end, to our cathode, which on this one, the cathodes are connected together, and it needs to go through these 2 watt resistors. So it'll go into the center one right here. Get on there. There we go. So now our tubes are DC ready, but if we try running it, it's not going to work. For reasons I explained in the first video, we are applying 135 DC, but the breakdown voltage is only 180, around there. So in order to lower this, we need that 120 or 150 volts AC, which we can do with another variac set to 150 volts AC. But here, we're just going to use 120, so I have another wire here, that this one we will use for 120. And all we need to do, this is the only thing we need to do to make this thing completely ready, is take our live wire and connect it. This thing's not long enough. I'll just do that. And connect it to the negative end of our full wave rectifier. So as you can see right there, we have connected our live wire to the negative end. So now, it's important to note right now, if we power up our AC and our DC side, everything on this actual circuit is going to have 120 volts relative to ground AC on it. Everything. So, don't touch anything until you have first disconnected your circuit. And I feel that should be common knowledge, but you never know nowadays. So, our tubes are pretty much ready. So, we'll just plug it in and we'll give it a test and see if it works. So now we have gotten everything ready. We are going to plug it in, or my mother is. And nothing exploded, so that's a good first sign. We will turn on our DC component, which is actually AC through a rectifier. And nothing exploded again. I didn't expect it would, so that's good. And now, when we touch one of the tubes, it turns on. But you noticed the other one turned on immediately. That's not supposed to happen, is it? And no, it's not. And if I touch the other one lights up. Now, I actually knew that was going to happen. We have forgotten to do one thing, or specifically, I have forgotten to do one thing. And that is, remember that grid I talked about? We haven't connected it anywhere, but the grids are connected together for both of these tubes. So, because the grid does not have a return path, because remember, the grid is in between the anode and cathode, and the current is traveling from the anode to the cathode, or specifically from the cathode to the anode. And so the grid is picking up some of those electrons that are going from the cathode to the anode. And since we don't have a return path, it's going to find a way to get back, and it's in turn going through the other tube. And that is actually enough to cause the other tube to fire. So, if we had a car panel like I do right here, and we connect all these tubes together without connecting the grid to the cathode, or specifically the negative end, then they will all light up after just one touch. That's not very realistic, is it? Well, unless you're doing cross-firing, but cross-firing doesn't even work that way. So, all we need to do to fix this is we just need to connect our grid to the negative end, and we can just connect it directly to the cathode if we need to. So I'll just do that quickly, and we'll see how these things work properly in the correct way. So all I've done here is I've taken one wire, specifically a wire that goes towards the grid on this pin right here, and I've connected it towards the negative terminal of the capacitor, which is basically the negative end of our full wave rectifier. So now both the cathode and the grid are at the same potential, and they'll have a return path for the grid now. So if my kind mother would please plug it in. And nothing exploded again, so that's good. And we'll turn our DC on. And nothing exploded again, so always look for the small wins in life. And now when we touch one of the tubes, it turns on, and the other one doesn't illuminate, because now we have a return path for that grid. And we can touch both on, and because we are using DC for our anode applied voltage, the tubes stay illuminated and stay conductive until we drop the voltage across, which we can do a few ways. Otis used basically a positive voltage across the cathode, which in turn reduced the voltage across the anode. But here we can just simply remove the anode voltage and the tube will extinguish. So we can touch one or the other, it'll work. So now I've shown to you how you can have gotten these tubes wired up the proper and correct way. Now, what if you wanted to, let's say, run a relay using these things? Well, you would think, well, why don't you just put the relay in series with the touch tubes? Well, the unfortunate thing is that relays are an inductive device, and inductive devices by their nature require a lot of current. But keep in mind, these tubes can only handle 25 milliamps of current. That's not a lot. So, next time, in the next video, we will talk about how you can wire something useful up to these things. And I will show you that in the next video.